Alright, so the last video for Unit 2, I'm going to just give an example of some excited electron configurations. So in topic 2, we learned all about these Bohr's models and the fact that when we add energy to an atom, electrons can become excited and jump to a higher energy level. So now we're going to integrate that into our electron configurations. So these two right here, this is the ground state configuration for nitrogen and for potassium. So we know that any electron from some ground state can jump to a higher state. So if we're going to draw a configuration that shows this, we're really having a huge number of options. So the only rules are we're going to take an electron from some energy level that it is in, and it's going to go somewhere higher where it doesn't belong normally. The only other thing that you got to know is they're not going to overfill shells. So even though it's excited, S is only ever going to hold 2. You're never going to have like S3. You're never going to have P7. You're never going to have F17. So you'll never hold more electrons than you can within the orbital. So let me just do a couple of examples for nitrogen. So one of them could be, let's take just one of this S orbital and bump it up here. So 1s1, 2s2, 2p4. So that level 1 electron has jumped up to level 2. Now, I could take an electron from here and have it jump up to some other crazy energy level. So I could say 1s1, 2s2, 2p3, and then let's say it just goes up to like 4d1, okay? It really can just jump anywhere as long as you're representing an electron going from somewhere lower to somewhere higher. So for potassium, we could do, let me just give you an example. Let's just say we've got 1s2, 2s2, 2p5, we'll take an electron from there, and we'll throw it up into a higher energy level. Let's say it goes to 4p1. Okay, so really you're not very limited here. The only thing that we need to do is take an electron from a lower energy level and represent it somewhere in a higher energy level, making sure not to overfill any orbitals. And that is an excited electron configuration.